operations and the simplex method. This video is going to walk through a simplex method example, but we're not going to go through all of the details of the simplex method. This is meant to help you use the calculator to solve the simplex method. And if you remember, one of the advantages of the simplex method over the method of corners is that it can be used for systems with any number of variables, whereas the method of corners is a graphical method and therefore limited to 2 variables. The example we're going to work here is a 2-variable example. As a matter of fact, it's exactly the same example as we worked in the method of corners video. And again, I'm not going to go through all the details of the simplex method. What I really want to focus on in this is how you could potentially use the row operations and matrix capabilities of the calculator to go through and solve a simplex method optimization problem. So our focus here is going to be on those row operations. And again, row operations I think are rather confusing things with the calculator. It takes a lot of practice to get used to them and to remember how to use them and input everything correctly. So while I do make this video available to you because I want you to understand the calculator has this ability, you are in no way required to use it if you're uncomfortable with this. Everything we're doing here can be done by hand using just standard row operations and the pivoting procedure that you learned in the Gauss-Jordan elimination method. Well, let's get started here on example 1. Again, we're being asked to maximize the objective function p is equal to 3x plus 2y, exactly the same as in the previous video. And that's subject to the same set of constraints. 2x plus 3y is less than or equal to 12, 2x plus y is less than or equal to 8, and our 2 variables x and y are both non-negative. Now, doing the simplex method, the first thing you would do here would be to rewrite your constraints, introducing slack variables, typically u and v, and you would also rewrite your objective function. And once you've done those things, you would create an initial simplex tableau, and I've already provided that for us here. Once you have that initial simplex tableau, you look at that bottom row to see if it has all non-negative values. In this case, it does not. And that means that we're not done. We do see some negative values here. Since we see negative values in that bottom row, we need to find the most negative value to identify a pivot column. Then once we know what the pivot column is, we need to identify the pivot row, and that will give us our pivot element. So I've identified x as the pivot column because -3 is the most negative entry in the bottom row. And then what I do is I take the values in the k column and divide them by the corresponding values in the x column, assuming that they are positive values. And I get the results, and I look for the smallest one. The smallest such result identifies the pivot row. So in this case, 12 divided by 2 was 6, 8 divided by 2 was 4, and the second row becomes our pivot row, and therefore the intersection of the x column and the second row is our pivot element. And I put that in a box here and made it blue. So then we need to begin actually working on this. All right. So the first thing we have to do in any pivot operation is make the pivot element itself a 1. We do that by multiplying the row by the inverse of the pivot element. In this case, by inverse I mean multiplicative inverse or reciprocal of the value. So that's 1/2. So we're going to take 1/2 of row 2 and replace row 2 with that. Here's the result you get. Let's see how we would do that on the calculator. Now before we can actually do that on the calculator, we have to put this initial simplex tableau in. So let's go to the matrix menu. We'll press second and the inverse, or x to the -1 key, which says matrix in the same color as your second key above it. And that brings up all these matrices. And we've done some other work with matrices, and we have a lot of things here. I'd actually like to clear those out so I don't have quite as much clutter. And to do that, we need to press the second key and the plus key, which above it says MEM. That stands for memory. All right, and then what we need to do is manage our memory, or DEL, delete entries. So we're going to choose option 2. We're interested in matrices, so we'll choose option 5. And here are my matrices and the amount of memory in the calculator they take up. To get rid of them, I delete them. I press the delete key. There goes A, there goes B, there goes C, there goes D, and there goes E. Now I don't have any matrices entered. All right. So now if I go back to the matrix menu, press second and the inverse key to get to the matrix menu. All my matrices are blank. So first I need to go over to the Edit menu because I need to create a matrix. Oops. All right, and I'm going to start by putting the initial simplex tableau in matrix A, so I'm going to choose option 1. All right, this matrix has 3 rows, so I'm going to type in 3. And it has a total of 6 columns, so I'm going to type in 6. So we have a 3 by 6 matrix. And I'm going to start with the first entry in the first row and work my way to the right, and then the second row from left to right, and then the third row from left to right, and enter all these values. So we're going to put in 2, 3, 1, 0, 0, and 12. And we press enter after that last 12. It takes us down to the next row. And we'll just continue to do this until we have the entire matrix entered. Alright, I have all my values in. Once I've finished editing the matrix, putting in those values in, I need to quit out of edit mode, so I'll press second and quit. And then I want to go back into the matrix menu, so I'm going to press second and matrix. It'll now show me that A is a 3 by 6 matrix, specifically this initial simplex tableau. Now going back to looking at this first operation where we multiply row 2 by 1/2. On the right hand side here I have what we do with the calculator. In order to start that, we need to go to the to the math menu under matrices. And the options we're going to use are at the very bottom of this menu, and the quick way to get there is actually to cursor up, which scrolls up to the bottom of the menu. What we want to do is to multiply the row by something, so we need option E here, times row. So I'm going to cursor up to E and press enter to choose that. And that gives me times row. Now I enter what we need to multiply the row by, which is 1/2. Then I need to tell the calculator which matrix is going to have a row multiplied by 1/2. So we need to go into the matrix menu, second and the inverse key. The only matrix I have to work with is A, so I'm going to choose option 1 for A, comma. And then the row that I want to multiply is row 2. So I'll press 2, and then I'll close the parenthesis. So that's telling the calculator to take row 2 in matrix A and multiply it by 1/2. You can kind of almost read it backwards to make it make a little bit more sense. If we press enter, it'll pop out our answer. Now we want to save that answer to work with, and you'll notice here that I've got this arrow in B. So I'm going to press the store key now that I've done this, and I'm going to choose second and go into the matrix menu and choose option 2 for B. I'm going to store that into matrix B, and it'll repeat. You could have done that all as a single entry. A lot of times I like to do the command first, kind of eyeball it and make sure it looks like it did what I expected, and then store it. Doesn't make a lot of difference one way or the other. This is just the way I tend to work. All right, so what we have in the calculator now is the matrix that you see here, the simplex tableau in the middle. All right, to continue working on our pivot operation, what we need to do next is put zeros above and below that 1. In other words, we need to take, as part of our pivoting process, once we have the pivot element of 1, we need to make sure that all other elements in the same column are zeros. So if we turn that first entry in the first row to a 0, we do that with the row operation, taking row 1 and adding -2 times row 2 to it, and then that is the new row 1. All right. In calculator speak, we're going to go into the matrix menu, and we are going to go over to the math menu. We're going to cursor up to get to the bottom of the menu, and we're going to choose times row plus. We're going to not only multiply a row by something, but we're also going to add a row. So we're going to choose enter there to bring that up. And I've already written that. What we're going to do is we're going to multiply a row by -2. So we put the -2 in first, then a comma. Now I'm working with matrix B. So I need to tell it that the row I'm going to multiply by -2 is in matrix B. So I go to the matrix menu and choose 2, comma. All right. The row that's going to get multiplied by -2 is row 2. And we're going to take the result of that multiplication, add it to row 1, and replace row 1. So that's the last thing we enter. So you should have this command here. And if you want to, we can just immediately store that into another kind of working matrix variable. I'm going to store it into C. So we can do that all as one step if you prefer, like this. So I'll press enter. And as we look here on the calculator, we see that we did indeed make that first entry in the first row 0, which is what we were trying to do. So that gives me a feel for the fact that I did the right thing here. And we now have this result stored in C. That result is the same as the result that I show in the middle of the line with those row operations in it, kind of the second line that you see here in my example document. To continue the pivot process, we need to put a 0 in the bottom of that column as well. Again, the pivot element has to be 1. Everything else in the column has to be 0. So in this case, we're going to take row 3 and add 3 times row 2 to it. That will give us a new row 3, and that will finish our pivot operation in this case. So I've written over to the right here the command I'm going to use, and you'll notice that I left the initial simplex tableau in A, and then I never change A. I like to leave that in there. That way if I make a mistake or something, I don't have to go back and re-enter that initial matrix. I can start again from scratch there. And what I'm kind of using B and C here for are just kind of two what I call working variables or working matrices to store intermediate results in, and I just bop back and forth. That way I kind of always have something saved from some work I've recently done. I don't necessarily have to always go all the way back to the beginning if it turns out that I did make a mistake. All right. For example, what I mean when I say that is in this operation that we're about to do, I'm going to work with matrix C. I'm going to store it into B. If I made a mistake, I haven't overwritten what's in C. It's still there, and I can try again and then store that result into B. So just trying to get some flexibility in here in the way that I work. All right. So let's do that operation. We'll go into the matrix menu, go to the math submenu, cursor up, and choose the times row plus command here because we're multiplying and adding. We're going to use 3 as a constant to multiply by. We're going to multiply by a row in matrix C. So we go into the matrix menu and choose option number 3, comma. All right, in this case we're multiplying by row 2, our pivot row, and we're adding the result to row 3 and replacing row 3 at the same time. And again, we can store that result directly into matrix B. We'll press the store key, go into the matrix menu, and choose option 2. Press enter. Our result comes up. We see the 0 in the place that we wanted, and that's our first indication that what we did is correct. It's not guaranteed or foolproof that what we did is correct, but it's a good indication. All right, so now matrix B looks like the result that we have here at the bottom in the very last row that I currently have up on the screen. And that finishes our first pivot operation. All right, so now we need to look at our bottom row and see if we can find any negative entries. If we can, that means we have another pivot operation to do. If we can't, that means we're done. In this case, we have a -1/2 in that row. Since we still have a negative value there, that says we have another pivot operation to do. So let me scroll up my example here, and we'll work through the second pivot operation. Oops, and I scrolled a little too far. Let me scroll back here. And almost there. There we go. All right, so I go through the same process I did last time. I find that most negative entry in the bottom row. In this case, there's only one. That's going to tell me what my pivot column is. In this case, that's the Y column. Then I take the K values, all right, those constant values, and I divide them by corresponding entries in the pivot column as long as those entries are positive. In this case, they both are, so I can do both divisions. 4 divided by 2 in the first row is 2. 4 divided by 1/2 in the second row is 8. So the smaller value is 2. That makes my next pivot element in the first row. We know it's in the second column, so it's the 2 that's blue and in the box. All right, and I leave it in the box all the way through so I don't forget where my pivot element is. That's just kind of a clarity thing. All right, so let me scroll up and show you what the last steps here look like. All right, if we go through and continue to work on this, the first thing we need to do is make that 1, get the 1. Our pivot element has to become a 1. It was a 2 to start with, so we're going to take 1/2 and multiply that by row 1, and that will give me a new row 1. To do that, we use times row, and since our last result was in matrix B, we're going to multiply row 1 in matrix B by the 1/2, and then I'm going to store that in C. So I'm continuing moving back and forth between B and C the same as I had been through the first pivot operation. All right, that gives me the result that we see here. Pivot element is a 1 once you're done with that row operation, that row operation. Then we need to make the other elements in the column 0. So if we make the 1/2 in row 2 0 first, our row operation is going to look like row 2 plus negative 1/2 times row 1. In calculator speak, that's going to look like times row plus negative 1/2 matrix C, since that's where our last result is stored, multiplying by row 1, adding to row 2. And I'm storing that into B this time. And that gives us the result you see here, and we definitely get the 0 in the right place. Our last operation, row 3 plus 1/2 row 1, that's because we have to replace this negative 1/2 in row 3 with a positive 1/2. So there's our row operation. In the calculator, that's times row plus. We're going to take 1/2 times row 1 in matrix B, and we're going to add that to row 3, storing that into C in this case. All right, and that gives you the answer that you see here. And we have a pivot process completed. Our pivot element is 1. All other entries in the pivot column are zeros. By the way, you'll notice I'm not doing this in the calculator. But this is left kind of for you to work with. Please feel free to pause this video and work through. Make sure that you can do this, though. I wanted to give you some extra practice and some visuals so that you could continue to work with these row operations through another pivot process. But I'm going to let you work through that. I've got the results and the commands here for you so you can practice with that. So as we look at this last simplex tableau here, we'll see that we no longer have any negative values in the bottom row. That means that we're done. So we should be able to read our solution from this. All right. Now when we read our solution, we know that if we have a variable above a unit column that is above a basic variable, that we read down to the 1 and across. So since x heads a unit column, that is x is a basic variable, we read down to the 1 in the x column and across to the 3. So x is 3. Y also heads a unit column, or that means that y is a basic basic variable. So we read down to the 1 and across to the 2, so y is 2. U and V, neither one of those head unit columns, so those are non-basic variables. Their values are both 0 in this case. P heads a unit column, and P always heads a unit column. This is one column that as you go through and do this should never change. If you ever do anything in the simplex method that changes this P column, this last column before you get to the constants, you've done something wrong. All right, we read down this column to the 1 and over to the 13. So there's our answer, the 0.32. P is 13. That's the largest value we can get for P subject to the constraints we're given. And if you remember from the previous video with the method of corners, that was exactly the answer we found there as well.